Welcome back for another deep dive. Today, we are going to be looking at hunger and how our bodies actually regulate it.
Yeah. That's something we all experience multiple times a day.
Oh, yeah, definitely. It's like one of those fundamental things. And you know what's really fascinating is that there's this whole system in place, a complex system to manage it.
Like an internal hunger thermostat almost.
Yeah, exactly. The apostat,
Yes, the apostat. That's exactly what it's called.
We are going to be using this physiology handout from Dr. Rasha Eldeeb to kind of guide our exploration today.
Great source.
Yeah, really in-depth stuff. So have you ever stopped and thought about what actually makes you feel hungry or full? I mean, beyond just like, oh, my stomach's empty.
It's a great question. It really starts in your brain, believe it or not.
Wow, the brain.
Yeah. There's a region called the hypothalamus, and that's where the apostat is. The apostat lives.
Okay, the hypothalamus. Got it.
And the apostat's always monitoring your energy needs, always sending out signals to either, encourage you to eat or tell you, hey, you've had enough.
So it's like this battle going on inside of us constantly, like the hunger team versus the fullness team.
That's a great way to think about it. You have two centers within the apostat. There's the feeding center. That was kind of your headquarters for hunger, always pushing you to eat. And on the flip side, you have the satiety center, which is like, okay, time to put the fork down. You've had enough.
So are there specific messengers relaying those signals back and forth between the brain and the body?
Oh, absolutely. There are. The messengers are called polypeptides.
Polypeptides!
They're basically molecules that are signaling, carrying messages about your hunger levels. And some of them, like neuropeptide Y, act like hunger hormones, telling your brain you need to eat.
Okay, so they're like the cheerleaders for the hunger team.
Exactly. And then you've got others, like the MSH on the fullness team, signaling to your brain, hey, you're good. You can stop eating now.
Wow. It seems so complex. Like, what factors influence which team wins? Is it just these polypeptides, or is there more to it?
No, it's definitely more. It's not just your brain. Your hormones, your blood sugar levels, even the temperature.
Okay, now that's getting interesting. Tell me more about how those other factors get involved.
Well, let's start with leptin. Now, leptin is produced by your fat cells. So the more body fat you have, the more leptin you produce. And it travels to your brain basically saying, hey, we have enough energy stored here. You can take a break from eating.
Okay, so leptin's trying to keep things in check, make sure we don't overeat.
Exactly, precisely. And then you have your gut, which plays a role too. It's not just about filling your stomach. As you eat, your gut releases hormones that signal, hey, we're getting full down here, like CCK, cholecystokinin.
Oh, wow. So it's like sending back up to the fullness team.
Exactly. It's amazing how interconnected all of this is.
Yeah.
Even blood sugar level plays a role too. If your blood sugar's stable, your brain's like, okay, we've got enough energy. But if it drops, it's like, uh-oh, red alert, need more fuel. And then those hunger pangs start kicking in.
That makes sense. But temperature, how does that play into all of this?
It's this thing called the thermostatic hypothesis. Sometimes you feel hungrier when you're cold. Well, that's because your body is trying to maintain its temperature. It needs to burn more calories to stay warm, so it ramps up those hunger signals.
Oh, that's so interesting. I do crave more comfort food in the winter.
Makes sense. And on top of all that, you've got things like how much your stomach is stretched, those hunger pangs you actually feel, even things like what the temperature is outside, even what you see other people eating. It can all influence your appetite.
Wow, it's not just as simple as an empty stomach then.
No, it's not. It's a whole symphony of signals going on.
Yeah. And, it makes you wonder what happens when those signals get all out of whack.
Well, that's a great point. And that's actually where we start getting into the territory of obesity.
Right. Which is a whole other can of worms. And we're going to open that can right after a quick break. So stay with us. All right, we're back. And, obesity is something that affects millions of people. It's a really serious health issue.
It is. It really is. And it's a complex one, too, with so many different factors at play.
Okay, so before we dive into all of that, how do we even define obesity?
Well, from a medical standpoint, we use something called the body mass index, or BMI.
Okay, BMI.
It's calculated based on your height and weight, and it gives us an idea of your body fat levels. And generally, a BMI over 30 is considered obese.
All right, so BMI kind of gives us a starting point.
It does.
But you said there are a lot of factors that contribute to obesity. It's not just as simple as eating too much.
Exactly. It's definitely not that simple. I mean, calorie intake is a part of it, but it's just one piece of the puzzle.
Okay, so what are some of the other pieces then?
Well, let's start with genetics. Studies have actually shown that our genes can influence how our bodies regulate weight and store fat.
Oh, interesting. So some people might be predisposed to weight gain because of their genes.
That's right. There is evidence to support that.
Mhm.
Like twin studies, for instance. They've shown that even when twins are raised in different environments, they often end up with similar body weights.
Wow, that's fascinating. So like nature versus nurture.
Exactly. But, genes are just one part of the equation. They might load the gun, so to speak, but lifestyle choices pull the trigger.
Okay, so genes might make someone more susceptible to weight gain, but their lifestyle ultimately determines whether or not they actually gain weight.
Yeah, that's a good way to put it.
So where does that leave us with things like calorie intake and energy balance?
Well, it all boils down to calories in versus calories out. If we're consistently consuming more calories than we're burning off through activity and exercise, that excess energy gets stored as fat, leading to weight gain.
Okay, yeah. It sounds pretty straightforward when you put it like that.
It is, in theory.
Yeah.
But the reality is there are other things at play too, like your metabolism, your hormones. They all influence the equation.
Oh, right. Yeah. We hear about those things all the time, like how they affect weight. So how do those fit into all of this?
Remember we were talking about the appestat before?
Uh-huh.
Well, that internal hunger thermostat, it can actually be affected by a lot of different things.
Yeah.
For example, if someone's constantly eating more calories than they're burning, their appestat can actually reset to a higher set point.
Wait, so you're saying the body starts to think that being heavier is the new normal?
In a way, yes. And that can make it incredibly difficult to lose weight and keep it off because the body is constantly trying to return to that higher set point.
Wow, that's kind of discouraging. So you're saying it's not just about willpower?
No, it's not just about willpower. It's about addressing those underlying hormonal and metabolic imbalances that are contributing to the weight gain.
Okay, yeah. It's starting to sound like a lot more complicated than just eat less and exercise more.
Right. And we can't forget about the psychological side of things either.
Oh, yeah, for sure. Emotionally eating, stress eating, those are definitely real things.
Absolutely. And those are often referred to as psychogenic factors. And they can really override our natural hunger and fullness cues, causing us to eat even when we're not physically hungry. Think about, you've had a stressful day. You reach for that point of ice cream. You're not doing it because your body needs the calories. It's a way of coping.
Yeah, we've all been there. So how do we deal with those psychological triggers then?
Well, I think a big part of it is recognizing those patterns in ourselves,
Yeah.
you know, and finding healthier ways to manage those emotions in those stressful situations. Maybe that looks like mindfulness practices, therapy, or finding other outlets that don't involve food.
Right, so learning to deal with stress in a way that doesn't involve reaching for a bag of chips.
Exactly. Now, getting back to the physiological side of things, we also need to talk about something called leptin resistance.
Oh, yeah, you mentioned that earlier. Remind me, what is leptin resistance again?
Leptin resistance is when your body basically becomes less sensitive to the signals from leptin, that hormone we talked about before, the one that tells your brain you're full.
Oh, right, right. So even though your fat cells are producing plenty of leptin, the message isn't getting through.
That's exactly it. It's like the brain is hitting the snooze button on the "we're full" alarm.
And that leads to continued overeating and weight gain.
Unfortunately, yes. And it makes it so much harder to manage your weight. But it's not just about leptin resistance. There are other things that come into play as well, like our NEAT levels.
NEAT levels, I'm not familiar with that one.
NEAT stands for non-exercise activity thermogenesis.
Okay, that's a mouthful.
It is. It refers to all those calories you burn throughout the day doing activities that aren't structured exercise.
Oh, okay, so like what? Give me some examples.
Well, fidgeting, walking around, even just standing up instead of sitting.
Wait, are you telling me that fidgeting can actually help with weight management?
In a sense, yes. People with higher NEAT levels tend to burn more calories throughout the day, even if they don't do a lot of formal exercise.
Mm-hmm.
It can help explain why some people seem to gain weight more easily than others, even if they're eating similar amounts.
Oh, wow. Okay, I'm definitely going to embrace my fidgeting habits from now on.
There you go. But, of course, we can't talk about weight management without talking about exercise. Lack of physical activity is definitely a major contributor to the obesity epidemic.
Right, yeah. It's no secret that we're a lot less active as a society than we used to be.
Exactly, and that has a big impact on our health, our weight, everything.
So, okay, we've talked about genes, calories, hormones, even fidgeting. It really seems like obesity is this incredibly complex issue with so many factors at play.
Absolutely. And it's important to remember that not all obesity is created equal. There are actually different types of obesity, each with its own challenges.
Oh, really? I didn't know that. Tell me more about that. What are the different types?
We can break it down into two main types: hypertrophic obesity and hyperplastic hypertrophic obesity.
Okay, those sound very sciencey.
They do. Hypertrophic obesity is the more common type,
Yeah.
especially in adults, and it basically involves an increase in the size of your fat cells. So the cells themselves get bigger.
So it's like the fat cells are like balloons that are getting inflated.
Exactly. That's a perfect analogy. Now, hypertrophic obesity is a little bit different. It usually starts in childhood, and it involves an increase in both the number of fat cells and the size of the cells.
Oh, wow. So not only are the cells bigger, but there are more of them too.
That's right. And that's why it's so important to address childhood obesity early on. The earlier we can intervene and promote healthy habits, the better.
So are you saying childhood obesity is kind of like a ticking time bomb in a way?
In a sense, yes. And it's not just about physical health either. Childhood obesity can affect mental health and social well-being as well.
So it's really important to address it from all angles.
Exactly.
Well, it's clear that obesity is a complex issue with some serious consequences, but we don't want to just dwell on the negative, right? Let's talk about solutions. What are the strategies for managing weight and improving health?
There are three main approaches: calorie reduction, increased physical activity, and in some cases, medication.
Okay, let's break those down a little bit. Starting with calorie reduction, what does that actually involve?
Well, it's not about going on some crazy crash diet or depriving yourself. It's about making sustainable changes to your eating habits.
So more about making healthier choices consistently rather than trying to overhaul your entire diet overnight.
Exactly. Focus on nutrient-rich foods, controlling portion sizes, and just being more mindful of what you're putting into your body.
Makes sense. And then what about exercise? What role does that play?
Exercise is huge. Not only does it burn calories, but it also helps build muscle mass, which boosts your metabolism. Plus, it's got a ton of other benefits for both your physical and mental health.
Right, yeah. So it's really about finding activities you enjoy and making them a regular part of your routine.
Absolutely. And then finally, there's medication.
Yeah, you mentioned that as a possible option. So when does medication come into the picture?
Well, while lifestyle changes are always the foundation, medication can be an option for some people, especially those who haven't had success with lifestyle changes alone or those who have certain health conditions.
Okay, so it's not a magic bullet, but it's a tool that can be helpful in certain situations.
Exactly. And these medications, they can work in a few different ways, like suppressing appetite, reducing fat absorption, even regulating certain hormones.
So it seems like a multifaceted approach is really the best way to go, like addressing the underlying causes, whether they're genetic, hormonal, psychological, or behavioral.
You got it. Obesity is not a one-size-fits-all problem, and the solutions aren't either. We need to find what works best for each individual.
Okay, so we've talked about how our bodies regulate food intake, and we've gotten into some of the factors that contribute to obesity, but there's another piece to this puzzle that we need to talk about: exercise. What actually happens in our bodies when we work out? So let's shift gears a little bit and explore that side of things next. All right, let's talk exercise. We all know what it feels like to push our bodies during a workout, but have you ever stopped to think about what's actually going on inside you when you're huffing and puffing?
Yeah, it's pretty remarkable what's happening at a physiological level. When we exercise, our muscles need more energy.
Yeah.
A lot more. And that means our cardiovascular system has to kick into overdrive to deliver that energy.
And that's where we get into this idea of oxygen debt, right? I remember Dr. Eldeeb mentioned that in her handout.
Right. Think about it like running a marathon.
Mm-hmm.
Your muscles are working hard. They need oxygen to keep going. But at a certain point, your body just can't deliver oxygen fast enough to keep up with the demand.
So it's like our muscles are going into debt, using energy faster than we can replenish it.
Exactly. And that leads to a buildup of lactic acid, which is what causes that burning sensation in your muscles when you're really pushing it.
Ah, so that's what that burn is, lactic acid. Interesting. But how do we repay that oxygen debt then?
Well, we repay it during recovery. When you stop exercising and you're resting, your body continues to take in extra oxygen, more than it normally would at rest. And that extra oxygen helps to break down the lactic acid and replenish your energy stores.
So that's why we're often still breathing hard even after we've stopped working out. Our bodies are still working to catch up.
Exactly. It's like we have to catch our breath. And speaking of catching our breath, Dr. Eldeeb mentioned that short bursts of activity like sprinting rely more on anaerobic energy pathways. What does that even mean?
Yeah, I was wondering about that too. Anaerobic sounds a little intimidating.
It's not as complicated as it sounds. Anaerobic basically means without oxygen. So when you're doing those really quick, intense bursts of activity, your body has to find a way to create energy without relying on oxygen.
So we're creating energy without oxygen. How is that possible?
Well, it's not as efficient as aerobic energy production, which uses oxygen, but it allows us to generate power quickly. Think about a sprint. You need immediate energy to get moving. There's no time to wait for your body to deliver enough oxygen.
Oh, okay. So we're tapping into a different energy system when we're doing those short bursts.
Exactly. And for those short bursts, up to 85% of the energy you're using is anaerobic.
Wow, that is amazing. But what about when we exercise for longer? Like going for a run or a bike ride?
Well, in those cases, your body starts to use more fat for fuel, and this process needs oxygen to work efficiently.
Right, that's why we hear about the fat burning zone when it comes to exercise.
Right, exactly. If you want to burn fat efficiently, you need to be exercising at a moderate intensity for a longer period of time. That allows your body to use oxygen effectively and tap into those fat stores.
Oh, okay, that makes sense. So how do we know what kind of fuel our body's using during exercise?
Well, there's something called the respiratory quotient, or RQ, which is basically a ratio that tells us what fuel your body is using.
A ratio. Okay, how does that work?
So an RQ of 1 means you're burning carbohydrates. That's typical for short, intense efforts. But as you exercise for longer and the intensity goes down, your RQ drops below 1, which means your body's starting to burn more fat.
So if I'm trying to build endurance and burn fat, I should aim for an RQ below 1.
That's right. It means you're working at the right intensity to make that happen.
This is really interesting. It makes you think about exercise in a whole new way, and it makes
Mhm.
you appreciate how our bodies just adapt. Like, remember when we were talking about oxygen debt?
Yeah.
Well, at the start of a workout, you often feel out of breath, your muscles might burn a bit, but as you keep going, something changes, right?
You're talking about the second wind, right?
Mm.
But as we call it in exercise physiology, the steady state.
Yes. What's happening when we hit that point? Why does it suddenly feel easier to keep going?
It's all about adaptation. At the beginning, your body is struggling to keep up with the demand for oxygen, hence that feeling of breathlessness. But as you continue, your body gets more efficient at delivering that oxygen to your muscles. Eventually, you reach a point where the lactic acid production and removal are balanced.
So we've essentially caught up on our oxygen debt.
Yeah, you've reached a state of equilibrium. Your body's adapted to what you're asking it to do. You're not gasping for air anymore. Your muscles aren't burning as much.
It's pretty amazing how resilient our bodies are.
It really is.
Well, I think we've covered a lot of ground today. From the way our bodies regulate our appetite to the incredible adaptations that happen during exercise.
Absolutely. We've talked about hormones, blood sugar, temperature, genetics, psychology. It's clear that these are complex systems, and they all work together to keep our bodies functioning.
And it's not just about understanding these systems from a purely scientific perspective. It's about what we can do with this knowledge. How can we use it to improve our health and well-being? So, to our listeners, I encourage you to think about what you've learned today and how it can apply to your own life. What small changes can you make, whether it's incorporating more movement into your day, choosing healthier foods, or finding better ways to manage stress? Remember, every small step you take towards a healthier you is a step worth taking. Thanks for joining us on this deep dive. We'll see you next time.